Okay, here is a quick video on our 91st lesson, which is mutually exclusive 2. So we're talking about Venn diagrams again today, and I'm going to start off with this example down here about students at New Haven Middle School. Now, it says that there are 147 students at New Haven Middle School. 33 students are in Honors Math and Honors English. 79 are in Honors Math, and 88 students are in Honors English. So, as always, when we start a Venn diagram, we want to start in the middle. So these students in here are going to be students who are in math and also in English. They're enclosed in both circles. So those are going to be these 33 students right here, because it says they're in Honors Math and Honors English. So 33 goes in the center. Now, I've used that number. 79, those are the people that are in Honors Math class. So this circle right here should add up to 79 people. There are already 33 in there. So 79 minus the 33 that are already represented leaves me with 46. So there are going to be 46 students over here. Let's see if I can erase that blue mark. Yeah, there we go. Okay. Now, we've used that number 2. There are 88 students that are in Honors English, 88 of them. So that means that this circle here, representing Honors English, should contain 88 people, 88 students. Right now it already has 33 students in it. So 88 minus 33 is 55. Okay, so now we've got that filled in. I've used the 88. And the last number that I need to use is the 147. So there are supposed to be 147 students in total here. Let's see how many students we have right now. 46 plus 33 plus 55. 46 plus 33 is 79 plus 55. 70 plus 50. This is how I like to break up mental math, by the way. So I'm going to break it up like this. 70 plus 50 plus 9 plus 5. So this right here is 120. And this right here is 14. So it is 134. Little quick mental math tips for you. So here's what I'm going to do. That means that I have 134 people inside the circle. But I'm supposed to have 147. So 147 minus the 134 that are already present, and that leaves us with 13 students unaccounted for. Those 13 are not in either of the honors classes. They might be in no honors, they might be in honors science, we don't know, but they're on the outside in this case, so that's where we're going to put them. Now let's answer a few questions based on these. How many students aren't in either honors class? That's the 13 on the outside. How many students are in Honors Math only? So Math only is going to be here, not these guys, because they're not only in Honors Math. So it's going to be 46. Now, what is the probability of picking a student who is in Honors Math? Well, these guys are, these gals over here, I don't know their genders, they're made up. So 46 and 33 are both counting towards math. So the probability of picking math is going to be 46 plus 33. That's going to be, oh, yeah, duh, 79. So there are 79 math students out of 147 total. Now the probability of picking somebody who is in Honors English. These people are in Honors English, and so are these. So if we add those up, we get 88 out of 147. Now here's the tricky ones. And thankfully, there are not too many of them. What is the probability of English given math? So another way of writing this question number 19, is what is the probability of picking someone in Honors English given that that person is in Honors Math? So we're given this, right? This right here is a given. So I know that this person is in Honors Math. That's what they're telling me. Whatever person I've chosen is in Honors Math. So what we're doing is we're essentially locking ourselves into this bubble right here. I don't care about anything that's going on the outside of this bubble because that is not my concern. I was given that this person is in math, so I don't care about any of this junk. So how many students total are inside that circle, the given math circle? There's 79. The given defines your denominator. And if that seems new to you, you should look back at the lesson called conditional probability. So this is going to be out of, I should make my pen a little smaller, these lines are not that big. Okay, so it's going to be out of 79 math. This is my denominator. So my numerator is not going to be everybody who's in English. It couldn't be. I'm locked into this circle. I've canceled them out of the situation, right? They're gone. So how many inside the circle are in honors English? Well, they're not, but they are. So it's going to be 33. I guess I'll just write it closer. 33 out of 79. I just want to clean this up. That was not what I wanted. That was not what I wanted. Well, it looks like this is not cooperating. Yep, it looks like I'll be drawing a new circle. Or just backing up all the way. There we go. Alright, so it was 33 out of 79. So given English, right, if we're given that they're in English, that means we're locked into that section. So given English means that we are only talking about inside here. Well, how many are inside of there? There are 88. Once again, my pen is too big. Okay. So there are 88 total for English. And how many of them take math? Well, 33 do. So the given always defines your denominator, and then the intersection tends to be what's on the top. Okay? Finishes out, the probability of none is going to be 13. I think that should be pretty obvious, right? So 13 out of 147 because there is no given condition. Save everything on the back that are interesting, and then I'll just go to the Venn diagram for the homework. Math or English, right? So this 22, this reads as math or English. Math or English means that we're including people who are in honors math, people who do both, and people that are in honors English. So when I add all of those up, I'm going to get 134 out of 147. English and not math, math and not English, those are these right here. So this is math and not English, right? Because these guys do take English, so they're not counted. This is English and not math, so it's just the 55. So 46 out of 147, 55. Oh wait, did I mix those up? I did. This one is 55, and this one is 46. Math or not English, this is an interesting one. So all I have to do is fulfill one criteria, right? I'm looking for one reason to check off a reason for a group to be included. So math or not English, yeah. So let's think of it like this. I'm going to make the math clause red, and I'm going to make the not English clause blue. And I'm going to color code the reason why I'm including them. So let's see. These get to be included because they're math. These get to be included because they're math. These get to be included because they are not English. These are not math, and they are English, so they don't count regardless. We don't want them in this case, okay? So all you have to do is fulfill one criteria. It doesn't matter that this is English, okay? Because it's math, and you only need to fulfill one. So 46 plus 33 plus 13. So that's going to be 79, 82, 92. So this is going to be 92 out of 147. And hopefully that'll help you answer question 26, which I think is pretty interesting. So pause here, try 26. Okay, so here's how 26 works. Let me color code this again. English is going to be green, and not math is going to be orange. So let's go back. Now English, these are English, these are English, and these are not math. So 33 plus 55 is 88, plus 13 is 91, 101. So this is going to be 101 out of the total, which is 147. And I'll just show you how you fill in the Venn diagram here, in case I showed you in class and it was too quick. Now there are 3 bubbles. Label them like this: math, barbell, and review. It's said that 12 students lift weights in barbell club, 9 people study in Regents Review, 10 people attend math club meetings, 1 person is in the barbell and math clubs, 5 people are in math club and Regents Review, 2 people are in Regents Review and barbell club, and 1 person attends all 3 after-school events. Now here's the thing, this might seem like a lot of information, so we want to have a plan of attack here. The plan of attack with a Venn diagram is to always start on the inside, the very middle. So let's see, the very middle here is this cell. I'm going to make my pen a little bit bigger so it's easier to highlight. So this cell here is the very middle. This is in all 3 circles. It's in the math circle, it's in the barbell circle, and it's also in the review circle. I'm not trying to be neat, so don't make fun of me. 1 person attends all 3 after-school events, so that's 1. I've used this number here. 2 people are in Regents Review and barbell club. So let's see. Regents Review is here, and barbell club is here. So it says that there are 2 people that are in both Regents Review and barbell club. But here's the thing, I've already got 1 person in this intersection region here. I've already got 1. So it says there's supposed to be 2, so 2 minus 1 is 1 left over. Now you can see that I have 2 people in the intersection between these 2. Now I've used that number. There are 5 people that are in math club and Regents Review. 5 people. So this here is math club, and this here is Regents Review. So in this section here, this hashed out section that I'm scribbling all in, this section here, there should be 5 people, but there's 1 right now. So 5 minus 1 is 4. And now you can see that there are indeed 5 people in this section. Okay. Now I've used that number. It says 1 person is in the barbell and math clubs. So here's math club, and here's barbell club. Now this is the region in which they intersect. There's supposed to be 1 person in there. Well, that's convenient. There already is 1 person. So I suppose this is 0. Now you see there's still 1 person in this shaded region. So I used that number. 10 people attend math club meetings. I'm going to switch to a different color, getting a little tired of red. Now let's go blue. 10 people attend math club meetings. So here's the math club. There should be 10 people inside this circle. How many are there right now? 1, 4, so it's 5 so far. Supposed to be 10. So 10 minus the 5 that are already present is 5. So it's 5 plus 4 plus 1 is 10. Cool. All right, so I'm good. So I've used that number now. It says 9 people study in Regents Review. So let's see. This is the Regents Review circle here. There are 4, 5, 6 in here already. But they said there's supposed to be 9. So 9 minus 6 is 3. Let's see if this adds up. 3 plus 4 is 7. Plus 1 is 8, 9. Yeah, so that works out. And so I've used that number. And last but not least, certainly not least, is 12 students lift weights in barbell club. 12 of them. So inside this circle should be 12 people. How many do I have now? 1, 2. Oh, but this is supposed to be 12, so if this is 10, 10, 11, 12. Yep, that works. So I've used that number, and now my Venn diagram is in great shape. So how many students are there total in my after-school events? 5 plus 10 is 15, 16, 17, 21, 24. So that should be the denominator for most of your fractions, or most of your probabilities here, okay? So good luck with that. Your homework was 30 through 43. Now, you may have forgotten a little bit about multiple trials, so I'm going to do 2 of those, 37 and 38. I'm aware that this video is getting a little long, but hopefully you're learning something. Would these be independent or dependent trials if I pick multiple students to help with a fundraiser? Well, if I pick somebody, can I pick them again for the same fundraiser? No, so it's almost like I'm removing them from the bag. If I had a bag full of students, when I pull somebody out, they don't get replaced. So this is without replacement. And that means that they are dependent trials. Now, what that means about the numbers is as follows. Every time I take someone out, the denominator goes down, right? So I have 24 students to begin with, right? So if I chose students to help me with a fundraiser, students who are in my clubs, what is the probability that that person is in barbell club, and then the second person's in barbell club, and then the third person is in barbell club, right? So let me make my pen a little smaller because I want to annotate on this tiny question here. This is person 1. This guy blue will be person 2. I'm choosing multiple peoples back to back. And I'm going to go sticking with the primary colors. This is going to be person 3. So I have to do multiple things back to back, and that means multiplication. So the probability of picking somebody in barbell, so I'm going to handle the red person first. How many people are in barbell? 10, 11, 12. There are 12 people in barbell out of 24 total. Make this smaller because I want to write on my line. Okay. So there are going to be 12 barbell out of 24 total. Now I pick that person, and that person is selected. They're out of the group. I pulled them out of the room. How many people do I have left? I have 23 total because I've taken somebody out. Well, how many barbell members do I have left if I've taken a barbell club member out? I should have 11 members of barbell left in the room. And just move this down so it's actually on the line more. Okay, better. Now lastly, if I pick a third person, I know that I should have 22 total left in the room. Dependent, get out of my way. And how many of those people in the room are from barbell club? Well, I had 12. I took one out. I took another one out. So I should have 10 left. And then because I'm doing multiple trials always means I'm going to be multiplying. And good luck with that. I'm going to do it in a calculator because I don't want to do that by hand. Okay, 12 over 24 times 11 over 23 times 10 over 22, enter. And now let's math enter because that looks like an ugly decimal. 5 over 46. That's a pretty good number. So the probability of that is 5 out of 46. Okay. And I hope that helps you with the questions that follow, and it's been a good reminder of multiple events. Right? Multiple events always means multiplication. Okay, see you in class.